Now we're going to be learning about the double-ended queue, also known as Deque. This is a type of queue that allows insertions and deletions from both ends. You can insert or delete at the beginning, you can insert or delete at the end. And because you can insert, delete from both ends, it supports the first in, first out, and the last in, first out. And we'll start by implementing this data structure using Python. Later on, we're going to learn about the Deque from the collections module. We'll start by creating our Deque class. So have class Deque. And we'll create our constructor. We have def double underscore init, and we'll have self. And we'll start by initializing our Deque. So we'll have self dot items is equal to empty list. So let's go ahead and implement the methods. And the first method we're going to be implementing is the append method. So we have append, we'll have self, and we'll have item. With the append method, we can be able to insert at the end. So have self dot items dot append, and we have our item. And because this is a double-ended queue, we can insert at both ends. With the append method, we can insert at the end. So let's go ahead and create a method for inserting at the beginning. And for this method, we're going to call it append left. So we have self and we have item. And for this operation, we're going to have self dot items dot insert. And we're going to be inserting at the beginning. So the index is going to be 0. And then we'll have our item. We'll close our parentheses. So this is how we insert at the beginning. So let's go ahead and implement methods for removing items from the Deque. And we're going to be starting with removing items from the end. So we'll have def pop, and we'll have self, we'll close the parentheses. But before removing items, we need to be sure that the Deque is not empty. So have if len self dot items is greater than 0, which means it is not empty, then we're going to have self dot items dot pop. Then we're going to raise an exception in a situation whereby the Deque is empty. So have raise index error, and we have empty Deque. Now to remove from the beginning, we're going to implement another method. So call this pop left. We'll have self, and just like the pop method, we're going to check whether the Deque is empty. So have if len self dot items is greater than 0, then we're going to have self dot items dot pop, and then we indicate the index, which is 0. Otherwise, we're going to raise index error, and for the message we'll have empty Deque. Just like the simple queue, we're going to be implementing the isEmpty method and the size method. So we'll start with the size method, and for this we have def size, and our aim is to return the number of items in the Deque. So we have return self dot items, and we're looking at the length. So I'm going to wrap this inside of a parenthesis and then provide len. So this is how we return the length or the size of our Deque. Then finally, let's determine whether our Deque is empty. And we have def is empty. and we'll have self here, and we're going to return len self dot items equal to 0. In a situation whereby the deck is empty, this is going to return true. But if it is not empty, it is going to return false. So let's put our deck into action. But before we do this, I'm going to be implementing one more method which returns the items or the elements in our deck. And here we have def display. We'll have self, and I'll simply return self dot items. So let's go ahead and create the object of our deck, and we have deck is equal to deck, and let's display. We'll have print deck dot display. So let's run it. So we have an empty deck, and we're going to start by inserting at the end. And for this operation, I'm going to have deck dot append. So let's put 10 there and run the program. So we have 10. Let me also insert at the end again. So I'm going to copy this and paste it. And for this, I'm going to have 20. Then run it. You can see it was inserted at the end. Now let me insert at the beginning. So we'll have deck dot append left. So let's have 5 and run. So you can see 5 was inserted at the beginning. So let's insert one more at the beginning, and I'll copy this and paste it below, and then change this to 1 and run it. So we'll have 1 at the beginning. Now the next operation we're going to test out is the pop operation. And so far we have 1, 5, 10, and 20. So let me remove elements from the end. So we have result is equal to deck dot pop. Then I'm going to print result and run the program. And we have an error here. And this is because I did not return the item removed. So we're going to have return here. And I also made the same mistake in the pop left. So I'm going to put a return here as well. And I run the program again. So we'll remove 20. And now you can see we're able to remove the last element in our deck. Now let's remove from the beginning. And for this operation, we're going to have pop left. And we'll run the program. You can see we removed from the beginning. So pop is to remove from the end. Pop left is to remove at the beginning. So the next thing we're going to do is to determine the size of our deck. And for this, we're going to have print deck dot size. And we'll run it. We have 3 because currently we have 3 elements in our deck. And if we want to determine whether our deck is empty or not, we're going to use is empty. So here I'm going to have print deck dot is empty, and then run it. You can see it is not empty. But let me copy this and place it immediately after I instantiated the class and run it. You can see it is true at this point because we've not done any insertion, and false at this point. So this is the basic implementation of the deck. Now we'll be implementing the deck using the collections.deck module. This version of deck is optimized for fast insertion and deletions from both ends. And to do this, we're going to start by importing the deck. And to do this, we have from collections, import deck. So we'll have Deque equal to deck. And to insert at the end, we're going to be using the append method. So we'll have deque.append will provide the item. So let's have 10. To insert in the front, we'll have deque.append left. So let's have 1. And let's go ahead and display our deck. And we'll have print deque and we'll run. You can see we have 1 and 10. So if I want to insert at the end again, I'm going to copy this and paste it. So let me change this to 100 and run it. You can see it was inserted at the end. And if I want to insert at the beginning again, I'm going to copy this. So let's change this to 0 and run it. And if I want to remove at the end, I will have deque.pop and run it. And if I want to remove at the beginning, I'm going to have deque.pop left. And that will remove the item at the beginning. So this is the Python implementation of the Deque. And if you need to implement Deque in your program, I encourage you to use this option. It is more optimized for Deque operations.